Okay, so like all waves, sound carries energy. And we need some way to characterize how much energy a sound wave carries. And to do that, we're going to measure the, not the energy, but the intensity. The intensity is, we'll call this I. It's measured, or it's defined as the power divided by the area. The power is in units of watts. The area is in units of meters squared. Remember, guys, that a watt is equal to 1 joule per second. It is an energy per unit time. And then the area, of course, is a distance squared. So our units then are going to be watts per meter squared. If we assume that the source is a point source, then the intensity can be written like this. That is that it's P over A, the power over the area, which is the power, that's the energy per unit time, divided by 4 pi r squared. Because if we have a point source that's emitting sound, it emits out spherically symmetrical, so that if I go a distance r from it, the total area that I'm covering is the area of a sphere. Here r is the radius of the sphere. Okay, so what happens to I as R increases? Well, as R increases, I decreases, and it's not a linear relationship. In fact, if I look at I versus R, as R increases, I decreases. It's a parabolic, it's an inverse square law. And this only applies if the sound is emitted in all directions, so that it actually is covering this total area. If that's not the case, then you need to figure out, well, what is the area? So for example, if I have, a megaphone that you're speaking through, then this at some distance away covers a different area. So that might be your area, for example. We'll just deal with spherically symmetric situations where I have the sound going out in a spherically symmetrical way. That's somewhat common. It depends how far away you are from the source. You can sort of approximate. But often, like if you're at a concert or something, then it's not the case that it is directed towards the people. Okay, here's some quick tests. You should try those. You should be able to answer them now. Now, when we're talking about intensity, we'll have two reference points. We have the threshold of hearing. You don't need to memorize these, but you do need to know they exist, and they'll be on your equation sheet. The threshold of hearing especially, which we'll use when we determine the sound intensity level, not the sound intensity, but this threshold of hearing is 10 to the minus 12 watts per square meter. And then the threshold of pain, and the threshold of pain is 1 watt per square meter. All right, just want to point out here, oh shoot, sorry. I just want to point out that there's a huge difference between the threshold of hearing and the threshold of pain. That's 12 orders of magnitude over which you can hear from just the quietest sound that you can hear to the loudest sound that you can endure. 12 orders of magnitude. Let me just let that sink in for a second. 12 orders of magnitude that your ear can detect sound. That's quite amazing. So, but these are dependent on the person, and it's also dependent on the frequency, which we'll talk about. The frequencies that humans are sensitive to later. All right, next we'll pick up with sound intensity level, which is different. This is sort of your more typical way to measure the loudness of sound when you measure it in decibels, and we'll look at that and learn about logarithms and what have you. For now, we'll stop.